Hey, welcome back. We're doing section 1.8, discussion for coordinate geometry. So there was a couple questions asked between the two classes, so let's dive into them, starting with number 5. So number 5 says, for the equation 3y equals x squared minus 36. The x-intercepts and the y-intercepts. So that's all it asks for. The x and the y-intercepts. Okay. So recall that the x-intercepts happen when y is 0. When y is 0, that is the definition of being an x-intercept. You're on that x-axis somewhere, right? And so if I plug in 0 for y, that gives me 3 times 0 equals x squared minus 36. 3 times 0 is, of course, 0, so that gives me 0 equals x squared minus 36. And I can solve easily by either factoring this into x plus 6, x minus 6, or I can add 36 to both sides. I'll do that one. Leaves me with 36 equals x squared. Right? And then I would just simply take the positive or negative square root here. And so if I square root this thing, I of course have to watch out because I have to assume that there's either a positive or a negative one. And so I end up with positive or negative 6 is equal to x. And there are 2 places then where I have x-intercepts. And there's 2 answers there. So pull them down. The answers are in ordered pairs, I think. Let me pull one down and see. Just kidding, they're not. So it's just positive or negative 6. That's all you're looking for. I'm going to erase this, so if you want that, pause the video now. Here it goes. The other side of this token is the y-intercept. The y-intercept is when x equals 0. Because again, that's the definition of being on the y-axis, is that x is 0. You haven't gone left or right. And so if I plug in 0 for x, that gives me 3 times y equals 0 squared minus 36. 0 squared is still 0. Minus 36 is just negative 36. And I can divide each side simply by 3. And I have y equals negative 12. So for my y-intercept, that happens at negative 12. Good. That's number 5. Let's look also at number 6, the next one. And it says, we have an equation 2y equals x to the 3rd. And then there's a bunch of options. We're looking for symmetry. So we're looking for symmetry about the x, y, origin, or both. The x-axis, the y, the origin, or both x and y. So if we think about what is happening here, if I look at a graph that has symmetry about, say, the y-axis, right? This is the y-axis. If you take this and flip it around the y-axis, it's the exact same thing, right? That's what symmetry about the y-axis means, right? And that means that if I have some point here, let's call this point x, and the point on the other side equally distance away is just then negative x, right? If I put in negative x, I get the same y value as if I put in x, right? So that is to say, if I plug into my function negative x, and I end up with the exact same function, then I will have symmetry about the y-axis. Right? Let's look at something with symmetry about the x-axis. Say this, sort of, there we go. Right. Now if I have some particular x value, I'll end up with a y value or the opposite of that value. Which is to say, if I switch my y from a y to a negative y, I should end up with the same function, right? So those are the two ways that we're going to test for symmetry about the x and the y, right? And then we'll talk about symmetry about the origin. In fact, let's do that now, because that'll save us a second. If I have symmetry about the origin, something that happens over here, oh, I've really done it to myself now. Rare. Yeah, something like that. I don't know. Whatever's happening down here, the idea, this is terrible. I'm not doing that. Something easier, right? There we go. That's not bad. The idea of symmetry about the origin is if you're standing on the origin and you look in one direction, you'll reach the function sooner or later. And if you look in the complete opposite direction, if you reach that function in the same distance, every direction you look, then you have symmetry about the origin. Right? So that is to say, if I plug in x, I get a y. But if I plug in the negative x, then I get that negative of the y. Right? So let's plug in some things and see. Right? We can test two of them in one go. If I replace x with negative x, and I get the exact same function out, then I have symmetry about the y-axis. If I plug in x if I plug in negative x in place of x and I get the exact opposite function, then I have symmetry about the origin. So let's plug that in and see what happens here. So I have negative x replaced with negative x, right? Which is to say this negative x, or this x here becomes negative x, so that is to say I have 2y equals negative x to the third. But negative x times negative x times negative x is what negative x to the third is. That's still negative x to the third. And this is the opposite. On the right-hand side of what I started with, I have the opposite function, right? And so since it's the opposite, that tells me that there is symmetry here. And it's symmetric about, since I plugged in that x and got the negative x, I have symmetry about the y-axis. All right. So let's take a look at the other one. The other opportunity that we have showing up is it could possibly be symmetric about the x-axis, and that is to replace y with negative y. So let's do that. We know it's symmetric about the y, and I'm sorry, this would be neither is the option here. If it's both, then it's the origin. All right. So let's replace y with negative y. That becomes 2 times negative y equals x to the third. But again, this is just negative 2y, and again, that's just the opposite. On the right hand, or the left hand side now, it's just the opposite. So I do indeed have symmetry about the x-axis as well, right? And if you're symmetric about the x-axis and you're symmetric about the y-axis, you are symmetric about the origin. And therefore, our answer in this one is symmetric about the origin. All right. Good. Let's take a look at number 7. We have y equals the square root of x plus 4. Okay. we're supposed to graph this, and then you just select it from the ones below, but we'll do it from scratch. So it's important to know that the square root of x starts at the origin and then kind of does that. Just kind of curves over, slows down, it still increases forever, but it's very slow increasing as you get to the right. This x plus 4 in here tells us that our domain changes a little bit. So if I look at my domain, I have x plus 4, that thing that's under the square root, has to be greater than or equal to 0 in order to be able to take the square root of it. And therefore, if I subtract 4, this is x is greater than or equal to negative 4. So instead of starting here at the origin, I now can start as far left as negative 4, right? So 1, 2, 3, 4. I have an open circle there, right? And really that's all it did is shifted everything to the left. This curve right here just went boop to the left 4 units, and I get the same thing, same looking kind of thing. And you can try different numbers, like if I try x equals 0, 0 plus 4 is 4, the square root of 4 is 2, so this goes through 2 right there, right? But it's the same curve, it's going to do that, so find the curve in the graphs that look like this. All right, let's look at number 9. Nine is that same function, y equals the square root of x plus 4. And it asks if there's any symmetry. And you can see it when we graph it. We already graphed it here, so I'll just get that graph back up there. It's not symmetric about the y-axis. It's not symmetric about the x-axis, and there's no way it's symmetric about the origin. So there is no symmetry. So it's not symmetric about anything. Now, that's good enough for that. Let's look at 11. Eleven says find the equation of the circle. With a center of 3, 4, and a radius of 5. So all I really need here is to know that the equation of a circle is x minus h squared plus y minus k squared equals r squared. Right? Where this h and k come from the center, h, k. H is the x value of the center, k is the y value of the center, and then the radius, r, is, in this case, 5. Right? So I just have to plug those numbers in here. That is x minus 3 squared plus y minus 4 squared equals r, which is 5 squared. And really the only thing that you can do is square that 5, right? So it's all of this, x minus 3 squared plus y minus 4 squared equals 25. And that's it. And that's one of our options. All right, let's look at 15. It says, show that the equation represents a circle by rewriting it in the standard form. And we're given x squared plus y squared. Is that too high? No, but it's good. Minus 16x plus 8y plus 74 equals 0. So we're going to do this by completing the square on both the x terms and the y terms. So the very first thing I want to do is rewrite this. And I'm going to color code it just so we can see what's happening. But I'm going to put my x terms together. So that gives me x squared minus 16x. Right? And I'll give myself some space and put my y terms together. So I have plus y squared plus 8y. And then I'm going to subtract the 74 off to the other side just to get it out of my way. Okay. All right, just checking to see if that's still in my field of view there. So I'm going to complete the square, which is to say I'm just going to look at my x terms for a minute. Right? Negative 16, I'll take that and divide it by 2, that's 8. 8 squared is 64. So I'm going to add 64 to both sides. And I'll do the same thing with my y's. And these parentheses aren't really doing anything, they're just grouping these guys together. Since there's pluses between the two, there's nothing weird happening here. I'm just kind of grouping them, that's all. I'll do the same thing here. Half of 8 is 4. 4 squared is 16, so I add 16 to both sides. And I've then completed the squares. What's in blue here is a perfect square trinomial. What's in orange here is a perfect square trinomial. That is to say that this is x minus 8 times x minus 8, which I can then write as x minus 8 squared. Plus, the orange one is y plus 4 squared. And on the right-hand side, I just have to add all of this up. Minus 74 plus 64 is negative 10, plus 16 is 6. And I have it. It's in the form that I want it. I can see here that my center happens at 8, positive 8, because this is x minus 8. You gotta watch out for these minuses here. And negative 4, because this is y minus negative 4 to give you a plus 4. So my center happens at 8, negative 4. And then the radius is the square root of that, so that's square root of 6. And that is 15, and in fact, that's also 14. 14 asks you for the center, 15 asks you for the radius. Good. All right, hopefully that was helpful. I'll see you guys again for section 1.10.